Marvel. Marvel at the goofiness. Yes.
Which one are we doing? The bottom one.
Oh, put the screen down.
It doesn't really fit it.
That's why I love your goofy data.
It's not yours.
No, it's not, is it?
No, I just did graph that was already on.
But,
Oh, ew.
but we also had a fourth of the chance as opposed to a half of the chance.
Now, hang on now. The thing is, when you think about half versus a quarter, you're essentially going to need a lot more data to establish those differences. When you have a half and a half are symmetric, right? What you guys just, this jump surprised the hell out of me. Jumping 185 to 45, I think is what you guys jumped to. You shouldn't have dropped that low to 45. That seems like an outlier to me. That makes me want to go back and rerun the experiment again. I won't, because I value your guys' time. It's going to be boring to do that. But I am envisioning a quiz for you guys for next week where you do a similar thing with technology. With technology versus the cards. Because I think what happened, I confused so many of us off the bat with how to deal.
Yeah.
That maybe some of us weren't dealing right. Maybe, possibly. If we eradicate that with technology, we get a better model. Guaranteed, guaranteed, guaranteed. Take the human error part of it out. Not that you guys are full of error. I'm full of error. Of course! Shuffling error.
Because sometimes cards come together.
Of course. That's what we start doing on Monday, is actually measuring that. Go, please, Ash.
Can you go through it and do another?
You can, I don't like doing that. Ash is asking a very good question. Can we doctor our numbers to make them fit the model better?
That's manipulating.
Well, it can be. It can be. What she's saying is, though, I know what the model was supposed to look like. What happened with ours, right? What I would recommend doing is go back. This is a 245, 246 answer, just so you know. Not a 105 answer. Go back to your experimental design and figure out where the discrepancy happened. It most likely isn't the mathematics. It's the actual experimental non-sampling error.
And the extraneous by like the version there.
Exactly. If you can eradicate the human error, you'll eradicate those differences too. 99 times out of 100. I mean, there's going to be the one chance you get random fluky data. Now watch this, just FYI. If I take away the 185 in the beginning, look at your data. Turn the equation on. That almost looks like it should, doesn't it? It's almost just like we didn't have the correct number to start with. The point value wasn't correct. Now I'm curious. I'm going to do a real quick X-brag on this. Real quick. I want to see what percentage it gets. I'm curious. Look at that.
Oh, yeah.
That's damn close to 75%, isn't it?
Right.
Yeah. It's almost just like we used the wrong starting value. Now, I know we didn't, because 185 of you gave me numbers, so it had to start with 185, clearly, right? But for some reason, that first move goofed up the pattern. I don't know why. I can't explain why. But once we got past that first one, you guys maintained the pattern just fine. Hell if I know why. I have no answer for that. But just that, on you go.
Isn't it?
I sense a burgeoning researcher here, making me very happy.
Isn't it good though?
That it doesn't fit the data?
Yeah, that our data is a little bit parsimonious as opposed to just being completely straightforward.
Stop using those big words around me, girl. I have a math degree.
Yeah.
Not your highfalutin English degree. What the hell does parsimonious mean? Don't make me Google it.
Disprovable. It means
Oh.
that
You took those words from the door, sister. Wait, disprovable?
it means that there are errors in the data.
Oh, yeah,
Because
for sure.
When the data is too perfect, then it's.
That's when Harrison Ford has to run from the one-armed man. When the data's too perfect. No, it's not that it's too perfect. It's so off.
Okay.
That I then start wondering why it's so off. Does that make sense?
Okay.
I love
And
parsimonious.
is
Thank you
the
for teaching me a
margin
word
of
today.
error where it's okay for it to be off?
That's what I did when I was trying to guess how many of you had hearts. I was putting a margin of error on my guess. When I said between 5 and 9, I was guessing 7, plus or minus 2.
Okay.
Margins of error take care of not the human error, but the randomness in the pattern. This is what I'm so excited about Monday with the randomness study, because we start looking at what happens when you start throwing cards. How long do you have to wait until you start seeing repeats of the cards? Those kinds of experiments. More cards, more coins, more dice in class starting Monday. But I like to start looking at that this was so much of a goofy. Look, it thinks we started with 67, not 180. It thinks we started with half of what we actually started with. That's what strikes me as odd too. So that's when I start looking at the actual design of the experiment. I love what you're saying. Even the words you didn't use, I don't understand. I love that too. Good? Please, Jury.
Have you done this experiment before?
Yes, and it's never come up like this before. Not that. It's off. They're always off, guys. They're always off. They're just not that off, right? And I love the fact that if we remove the initial value, we actually get a really, really good fit. See, look at the fit. Here, watch. Here's the graph with it. Here it comes. I mean, look at it.
Oh, yeah.
It's gorgeous. It fits it beautifully. Even with this goofy 5 right here. The run of 5, which shouldn't have happened. Should, quote unquote, have happened. It's pretty badass. It's pretty cool, huh? Anyway, I love data because data just shows itself to us. Here's my data. Parsimonious. Now, I want to do one more quick data set. One more quick data set, and that's all. Both of the examples we just looked at, the coin flip and the card pulls, represented what's called exponential decay. That means, as the experiment progresses, what happens to our y values?
It goes down.
They go down. We lose y values. We're maintaining at a loss, if that makes sense, right? So the maintenance value is half. That means we're leaving behind 50% of what we had. That means we've lost what we've had. The maintenance percentage is 75%. That means we've lost 25% of what we had. Not every exponential model is a loss, though. Somebody actually asked for this one earlier. Thank you for reading my mind. I've got here, let me shrink it down so you can see it. These are census data numbers from 1900 up to 2011. U.S. Census Bureau. U.S. Census Bureau. You can't see it. Got the wrong damn, there! U.S. Census Bureau, thank you. Somebody say something next time. What do you use that word all day now? Completely wrong. So what we've got here is in 1900, the census tells us there were 76 million Americans in the U.S. 1901, 77.5, 1902, 79.1, 1903, 80.6. So I've done a similar study for the city of Bend when they're trying to predict. Oh, Josh, go ahead.
This would have been really helpful on the quiz.
Yeah.
Because on the cancer quiz, it asked for how many men are in the U.S. at any given.
Didn't I give you a hint on how to find that?
You did, but I
Pretty much the same thing I did to get this.
Yeah,
You're welcome.
Google, but
Google's your friend. That's how I would have figured out what parsimonious meant if you didn't tell me. I told you, go Google it. And then take half of it for the men.
Yeah.
You're welcome. Teach a man to fish.
I just says okay.
Teach a man to fish. That's the thing. Teach a man to fish. And remember, quizzes. If you don't like a quiz, don't do it. I looked at those 2 quizzes last week and I'm like, I guarantee nobody's going to do this one.
Really?
They're all going to do this one. They're not going to do this one. But I figured I'd give you 2 options in case. You choose wisely. Don't be like that Nazi from Indiana Jones and the Last Crusade. Yeah.
Kind of random. For the next few weeks, are we still going to be getting about 2 quizzes a week?
My plan is to have at least 2. Yeah.
At least 2.
That's my plan. Yes, my plan. Now, look at these numbers. Notice they're growing on average. But look at also what happens. Look at also what happens. What I've done is, in this first column here, I've got the raw data amount. The population of the U.S. goes up each year. 1.5 million, 1.6 million, 1.5 million, 1.5, 1.6, 1.6, 1.7, 1.7, 1.9, 1.45, 1.5, 1.5. So I did that to see if the data was growing linearly. Per year, is the U.S. picking up the same number of people per year? So when I look at that, oh, Amy, go ahead.
I'm just looking.
She's looking at what I graphed over here.
Yeah.
Now, you could agree that maybe it's linear, but I don't think so. Now, this is not a mathematical guess. It's a logical guess. How do people come into the country? How do Americans come into the country?
Either
They're
birth or
born or
Birth or immigration, right? Now, birth is not a linear thing. It's not a linear thing, okay? You have 2 that might become on average 2, and then those 2 might become on average 2 more per, and it starts a spider web out. The human race doubles, FYI, the human race doubles every 40 years. The human race doubles every 40 years.
Wait a minute, if 2 people have 2 kids, that's just 1 for each.
Careful now, careful. The human race doubles every 40 years. The human race doubles every 4. I'm just going to say that. I don't know, I'm not explaining why, I'm just saying it does. In 1960, there were 3 billion people. In 2000, there were 6 billion. If you back up to 1920, there were 1.5 billion. The UN uses these numbers to predict the carrying capacity of the Earth, when the Earth will be quote-unquote full. Now there's all kinds of arguments. There's all kinds of arguments. You could stick every single person in America in the Grand Canyon, and they would have roughly the amount of space in this room to themselves if you were to do that. That's how big the Grand Canyon is. 330 million Americans, you could stick them all in the Grand Canyon, and they'd have roughly this amount of space to themselves. Now, but some of those people, of course, are floating in midair in the Grand Canyon. So that's not a way to live, right? I've also been told you could shove every American into the state of Texas. You could.
Why would you ever do that?
I'm not saying you should. I'm not saying you should. I'm just saying you could physically do that, right?
I'm not going.
It's okay. I'm not either. I'm staying here. You guys all just work and go to Texas. Me and you hang right here.
Just go to Austin, you'll be good.
But the Austin's good. But that's not. You're missing the point. The point is there's a carrying capacity beyond which the Earth cannot handle. So we want to look at population numbers. Go.
Is this what they did in China?
Say that again.
Is this what they did in China?
I don't know what China does, honestly. Time out. Don't get too sidetracked. I don't know what China does. I don't understand China. Don't get too sidetracked. I don't turn this into a geopolitical class. I want to look at just the U.S. data. Now watch. I wanted to know how the U.S. population is changing. So, I made an assumption that it was changing exponentially because I graphed the data and I saw this. Now that looks fairly linear. It looks fairly linear. The problem is, if you slap, can I do this? How do I do a trend line? I keep forgetting how to do it on, I think it's over here. Yep, there it is. If you do a trend line, it doesn't really work. It doesn't really work. It underestimates at the beginning, and it starts to overestimate, and then it begins to underestimate again. It almost seems like there's a bend in the data that the line is missing. And it's not so much that it's missing the line, it's that it's missing it in a predictable fashion. That's what drives me nuts. We know best fit lines aren't perfect, but when they are predictably missing, that's when I'm like, okay, something's up that I don't like here. Does that make sense so far?
Yeah.
So, I can also try, if you want, I can try one of those quadratic trend lines. Let's try a quadratic. More trend line options. Polynomial order 2, I believe, is the one I want to use. Oh, and there it is. Close it up. And that looks pretty good, doesn't it?
Yeah.
That looks damn good. But the problem is, do you remember how we checked for quadratic behavior in class? You probably don't. It's okay. It's been about a week and a half. You look at what are called the second differences. These are the slope differences. These are the second differences. And what we noticed with me on my bike was that these were constant in a quadratic model. What do you think about these? Those are anything, so it looks pretty good, but the problem is it doesn't solidify when you analyze it too much mathematically. So that's when I said, okay, maybe it's not quadratic. Let me look at the exponential change year to year. Like a coin flip, is there a maintenance percentage? Okay, so let's see. I'm going to take this value and divide it by the value above it, and I get 1.02. That's a percent. It's 102%. That means the maintenance percentage is 102%. What does that mean? What is it? The maintenance percentage is 102%. What does that mean? We added 2% to the 100 we already kept. We're not losing. We're gaining an additional 2%. In the coin flips and in the card pools, we were losing people each time. Here, we're keeping everybody we've got and adding 2% to it. It's actually true maintenance if you think of it that way.
So it's a 2% increase.
From 1900 to 1901 was a 2% increase. So then I said, let's just see. Let me just see how it carries down. And I said, holy
No way.
stuff.
Wow.
And I kept going. Now look down here.
Oh, it starts to
can't
take
see that
over.
control.
Well, World War
Yeah.
I. There's lots of reasons we can, there's World War I, there's birth control, there's all kinds of stuff.
Depression, yeah.
Keep it going. Now look, depression era, pre-depression. The pre-depression doesn't make sense. That seems like you'd be booming, roaring 20s kind of thing. But maybe roaring 20s are tied with contraception. Who knows? I mean, I'm playing in a region I don't understand.
Industrialization.
Yeah.
There's
Very parsimonious. I don't know. No, this is population of the country.
So if babies died really young, was it?
Well, or immigrants.
Okay.
I don't know where the numbers are coming from. But guys, don't lose sight. Look at the percentage of growth. It's staying almost perfectly at either 2 or 1%. Look, guys. Look, it shifted to 2 right about.
Where's the baby?
Now, this one, time out now. The jump here, 1947, I can attribute to one of two things. baby boomers after World War II,
Yeah.
and the annexation of Hawaii and Alaska, which happened roughly around that time too. So it's kind of an artificial boom in population with that, because we picked up people that were already there, but now we're calling them Americans. Does that make sense? But now watch, it maintains. Even after those couple years, this maintains. Now it shifts back again in the 60s, and then it stays at about 1%. But you see what we've got here, friends? You've actually got almost pure exponential growth. So the model for America would be y equals, I forget the original starting amount.
X plus 2%.
You got it. It's 76 million. 76 million. That's your base amount if we're starting at 1900. Nobody says you have to start at 1900. You could have started in 1947, you could start in 1950, it all depends on where you want to start. I'm just starting with the beginning of my data. 76 million is my base amount, my starting amount. The maintenance amount is going to be 1.0. Now here's, what would you call it? 1.5% if you want to average it out over the entire period of time?
1.0.
Well, it can't be 1.0, because that means we're not growing.
1.0502.
We're going with 1.02?
Yeah.
We're going to call the whole thing 2% growth? That's okay, I can live with that.
Or 1.
Or 1, or 1.5. See, you pick. We can actually fit it mathematically if you want to. But you can pick 1.015, you can pick 1.01. This would be 1% growth annually. This would be 1.5% growth annually. That would be 2% growth annually. Do you see the extra little 1 in front, what it does? It means you don't lose anybody. This is called exponential growth. You're growing. You're growing, you're not decaying like the other ones were doing. Does that make sense? So, and let's let Excel fit the model. Let's let Excel do it for us. Whoops. Up here. Let's get those curves off of there. Oh no, I gotta do it this way. Remove the trend line.
What year did you stop at?
I did. I used the entire data set.
Yeah.
All the way, well, it's 2011. We can also Google to see what the population is right now and see if it fits on our model. I think we should do that. Let me throw a trend line on real quick. Now, you know what? The hell with it. Let's just use our models.
Okay.
What is the population of the U.S. right now? I'm going to guess it's 330 million or something like that. You guys got it? $316 million. Okay? 316 million.
That was 2014.
That was too well, and they're not going to have 2014 because they haven't finished counting yet. Let's see how that fits our predicted model. Okay? Let's see how that fits our predicted model. So if we use our TIs, hang on. This is going to be years since 1900. This is going to be years since 1900, right? So I'm going to switch over to the TI real quick. I'm going to slap my model. 76. Actually, can you guys mind if I just put 76 instead of 76 million? We'll just know it's in millions. Is that cool? And I'm going to do 3 different models. 1.01 to the X.
316.1.
1.015 to the X. And 1.02 to the X. I put all 3 of our models in Y1, Y2, Y3. Then I'm going to go to my table and I'm going to stick in 2014, which would actually be 2014 would have to be 104. Correct? 104? Would that be 104? 114? 114. Thank you for looking at it. 114?
Yeah.
I'm going to go to the table and look. Here we go.
Looking for mine, I was like, is this your calculator?
Oh, God! Look at the differences! Look at the differences! If we use the 1%, we wickedly underestimate.
Right.
If we use 1.5%, we underestimate. If we use 2%, we overestimate. I think we just figured out where the rate is. It's somewhere between 1.5% and 2%. Probably 1.75%, somewhere like that. Why do you care about this? You might not.
It's just interesting.
It's interesting because what if you're trying to plan resources for a small town like Bend?
Right.
The City of Bend Police called me in a few years ago and said, look, we're having budget cuts. We have to figure out where our need is going to be. Can you figure out where the population is going to be in 10 years? I said, no. But I can try based on your past performance to see where I can be plus or minus. I did basically this for them.
I bet they look.
What's your margin bearer?
I don't remember, it was 10 years ago. I can tell you the documents if you want them. Hell, I know the spreadsheet's saved.
So what does it look like from 10 years ago to now?
I haven't looked at it since then. I haven't looked at it since I did that work for him. It was doing this thing. Now, what I'd love to see is if it started doing this, and then corrected, haven't looked at it since. Properties or populations? It went down.
Yeah, it went way down.
Interesting.
And then Facebook came and it's kind of.
Yes, it's kind of creeping back up again.
But it went, they lost like
It-
10,000.
It died, oh, wild. Absolutely wild. What's up? Oh, we got cards, yes. If you don't mind returning the card, that'd be great.
There's the box over here.
Yes. Good for you. You meant to live it.
Right, but in the.
Fix one of them.
Right.
Only if you get a chance to check with people, make sure you're doing it, which you think is correct. Only turn the ones you're solid on. Yes. If you're turning in ones that aren't good, they're not helping you. So check with people, check with neighbors, make study groups. Good? You got this, sister. I know you got this.
Yeah, I've got a I've got names.
Yeah, you do. Let's keep it. Well, let's just take the hard copy too, that's perfect.
That's what I put on.
When you say hard copy, was it like a network problem?
So that balances it out.
A PDF? Just taking a scan of it and sending it a
No, I
PDF?
just did in the write-in thing.
Oh, yeah, I'm still waiting to hear from Christine about that. I can't put comments on the written submissions part. I don't know why, I just can't. And I don't know if the Blackboard glitch or if there's some setting I have to check somewhere. So if you ever get a chance, just scan your PDF and send it to me that way.
Okay.
And that way I can actually put comments on your stuff.
Okay.
Cool?
Yeah.
Excellent.
I was just curious,
On Monday, it's sitting, no, you give it to me Monday, right? It is sitting on my floor to get ready this afternoon.
okay, so probably by tomorrow.
Oh, it'll be in the grade book. Today, I remember to send me an email at some point today, asking me to send out progress reports again.
Okay, so yeah, mine is like.
Exactly, because your exam is not right, it's not right. And I have to, the problem is, this weekend's gonna be a Zoom. So I'm gonna have to get those out today or tomorrow. So send me an email tonight, and I'll take care of it. Cool, we got it.
I don't know, sometimes it's just quizzes.
Office.
Well, yeah, if we had something, let's put together.
Yes, bring it to my office, and I'm not there sliding under the door.
Okay.
Oh,
Everything's turned on Blackboard. Well, you can't now because the Blackboard links are gone, we started class. Rock on. So just print them and bring it to me.
I have them.
You do? Bring them right here, drop it right here. Perfect.
Okay,
Pam,
I am trying to do a renegade coupon.
you are, good.
For 10
Good for you.
points.
For the quiz?
Well, for one way back, I would like to have 10 points back.
For the quiz, right?
For one of the quiz.
Yes, ma'am.
Okay, in the rainy day thing, it says to copy and paste your old answer onto the sheet. Well, I can't copy and paste anything on my scans.
Yes, you can. Yes, you can. You have a scan saved as a digital file, right? You got it
It's-
saved on your computer?
Yes.
Let me show you, come here.
Okay,
So let's suppose this is your scan right here.
okay.
You're going to go to what's called the snipping tool.
Oh, it's,
And there's a video explaining how to use it on the assessment page in case you need. Cool, you got it, sister. We got this. We got this. 10 points coming back to you.
thank you.
You're welcome.
Here's your cards.
Good for you. Good for you. Thank you.
Oh,
Thank you for the cards. Very good, very good, very good. Yes, very good. Excellent. Sure. Lots of one-bar stats, that's good. So let's see, you got, that looks fantastic. What do you want me to set up? What am I setting up?
Well, just go to, okay, those,
Yeah, they are.
They're all right
You're
then.
golden.
okay.
Golden, not a problem. Perfect. Kyle. We'll make it work. You are welcome. I'm so pissed that empty food stuff is still here.
Right, where were we supposed to sit?
I don't know, right? Why isn't there food in this? Better question, why isn't there food in there? Seriously. I'll sit right next to it, there's bacon in that container. Just saying. Start all the vegetarians in the house. There. There's a sous vide here. Oh my gosh, right?
I got like so frustrated about that looking at it, and I was
It took like 3 hours.
Oh my goodness.
I hated it.
What?
Well, it's like hard.
Yeah, it wasn't hard. It's just easy.
Yeah.
But someone started it last night.
I don't even know if I agree with that. Last night.
I didn't see it last night. Making you do it over.
Recording.
I did it all last night.
No need for that.